Okay, in this class, remember in the last class we spoke about the slope-intercept form of the equation of line, which is always in the form y equals mx plus c, where m is the slope and c is the y-intercept. In this class I want to talk a little bit about what's called the standard form of the equation of a line. It's just another way to write the equation of a line. And it looks like this. It just means we get all our terms on one side and 0 on the other. Sometimes you'll see it written as ax plus by equals, let's just subtract c from both sides, equals a constant. So getting your x and y terms. But with standard form, what we do is we get all our x and y terms on one side of the equation, usually with the constant as well, but sometimes the constant can be left behind on the other side. So let's just look at a couple of very quick examples. This says write the line L. L is the name of the line. There it is. That's kind of the notation. We write the name of the line, then a colon, and then the equation of a line. Write the line L in standard form. Before I do, from previous class, we should be able to straight away say what the slope is and the y-intercept is. And every time you see a line, that should go through your head. It doesn't matter if it says what's the slope in the question, you should be immediately thinking about slope, y-intercept. This line will be decreasing. Its slope is going to be -1 because -1 is the coefficient of x. Its y-intercept is 3 because the constant here is 3. I know it's 1y equals everything else. That's slope-intercept form. If I was to graph it, I'm not going to do it perfectly here, but what does that mean, a graph of that? Well, it means y-intercept at 3 there, and a slope of -1 means every time we run 1, we rise -1. So we'd have a line going kind of down like that. That's essentially what we would get. Okay? That is not to scale. That's a very rough picture. You would use your squared paper to do that. But, what does the question say? The question says write it in standard form. So, in order to write it in standard form, I've just got to be good at manipulating equations. I've got to understand the properties of equations that we spoke about back at the start of the year. The first property of the equation I'm going to use is the addition property, which says if equal quantities are added on both sides of the equation, then the two sides remain equal. The second property I'm going to use is the subtraction property of equations, which says if equal quantities are subtracted from both sides of the equation, then the two sides remain equal. So what I'm doing is I'm adding x on both sides. I'm subtracting 3 on both sides. So if I add and subtract equal quantities on both sides of the equation, then the two sides will remain equal. So what will we get on the left? Well, it's positive x, positive y, -3. Generally with variables, we'll put them in alphabetical order. I'm going to say that's x plus y. Subtract 3, and over here -x plus x is 0, positive 3 subtract 3 is 0. That's giving me my 0. So L, the line L, can be written in the form x plus y subtract 3 equals 0. That is in standard form. Okay? In order to do it, I have to know the following properties. The addition property, which says if a equals b and c is equal to d, then a plus c is equal to b plus d. Okay? And I could have, the subtraction property is almost identical, except it replaces that plus with a minus. The multiplication just replaces that plus with a multiplied. The division replaces the plus with a division. Those are 4 important properties of equations. If equal quantities are added on both sides, or equal quantities are subtracted on both sides, then the two sides of the equation remain equal. So x plus y minus 3 equals 0. That's exactly the same line as -x plus 3. Okay? And a good idea would be just to go and look at those lines on GeoGebra. Just go and have a look, type them into GeoGebra and see what they look like. Take out a GeoGebra file, type into your input bar y equals -x plus 3. Let's do it. Here's this. I'm just going to type into my input bar up here y equals negative x plus 3. There it is. You can see a y-intercept of 3, slope negative 1. We knew that already. And I'm also going to type in the standard form, which we said x plus y minus 3 is equal to 0. And you'll see there it's exactly the same line. If I remove one of them, there's that one. If I remove that one, there's that one. GeoGebra has called this one equation 2, and it has called this one f for some reason. Okay, so that's those equations. They're the same line, they're just written in a different form. So standard form ax plus by plus c equals 0. The other thing we can do is switch from standard form into slope intercept form. So I have this line here, it's called t, and the equation says 2x subtract 4y plus 12 equals 0. And I'm going to, write in a slope intercept form, and then I'm going to graph it here. So 2x minus 4y plus 12 equals 0. One thing we want to do is get y's on their own. Remember, it's 1y equals mx plus c. So I want to get 1y. I also want the y's to be positive. So actually I might start off here by adding 4y on both sides. And write that as 2x plus 12y, or plus 12 I should say, equals 4y. And the next thing I'm going to do is divide on both sides by 4, using the division property of equations, which says if both sides of an equation are divided by the same quantity, then the two sides will remain equal. On the left hand side, we're distributing this division by 4. 2x has to divide by 4. That will give me 1/2 of x. 2 divided by 4 is a half. And then 12 if divided by 4 is 3. And 4y divided by 4 is y. That was the whole point of it. So a couple of things to note. And the other thing I could have, instead of a half x, one thing I could have written instead of 1/2 x like that, I could have written x over 2. One thing you could not write there is 1 over 2x. Be careful with that. So a half x, notice where the x is placed there when I write a half times x. We could write as x over 2. But that's in slope intercept form. Let me just turn it around. Again, this line, the question is called the line t. T colon, t is the name of the line. The equation of the line is y is equal to 1/2 of x plus 3. I'm using something called the symmetrical property of equations, which says if a equals b, then b equals a. If a half of x plus 3 is equal to y, then y is equal to half x plus 3. So what can I gather from that? Well, I can gather a couple of things. That's in slope intercept form. The slope is the coefficient of x. The slope is going to be a half here. That means every time I run 2, I rise 1. Remember, slope rise over run. And the y-intercept here is going to be 3. So how will I graph that? Well, pretty straightforward. I'm going to just mark in a couple of points, and you can mark in 2 really, but I'm going to mark in several just to be a little bit more accurate. I'll make them bigger than I need to, so it's more obvious to you looking at this. So I'm going to put in the slope, or the point. I'm going to start with the y-intercept, which is 3 there. That's my first point. And now what I'm going to do is I'm just going to kind of rise and run. So remember the slope 1 over 2, that's rise over run. So every time I run 2, I rise 1. Run 2, rise 1. And I don't really even need those dots written in, run 2, rise 1. There we are. So going backwards, I'll be falling 1 and running negative 2, just reversing the process. Fall 1, run negative 2, fall 1, run negative 2 there. Okay, so if I go to graph that line now, I need a ruler or a straight edge of some description. So just going through all those points. There they are, all those points that I've picked out. Be really accurate there. Okay. Doesn't give me any particular domain for that line. So, what I might do is just extend that line on to the end of my graph. And the other thing I want to kind of get across is because there's no domain given, that means that's going on forever and ever. So I'm going to just put an arrow at the end there. Because without the arrow, it's not a line, it's a line segment. The arrow is explaining that this line continues forever and ever in that way. So we can graph these things in slope-intercept form very easily. If we're given standard form, we can pretty easily change it into slope-intercept form. Find the slope, find the y-intercept. Once I have a point and once I have the slope, I can plot this line. Okay. And then lastly, finally, slope-intercept standard form to slope-intercept form. It says find expressions for the slope and y-intercept of lines whose equation is in standard form. So I want to find an expression for the slope and the y-intercept of a line who looks like this. Remember, to get it in slope-intercept form, I want to get the y's on their own on the left, so I'm going to use the subtraction property. If equal quantities are subtracted from both sides of an equation, then the two sides will remain equal. Subtracting over here, the ax's will cancel, the c's will cancel. So what I have is b is equal to negative ax minus c. The next thing I'm going to do is use the division property, dividing on both sides by b, and the division property says if both sides of an equation are divided by equal quantities here, then the two sides will remain equal. On the left hand side, by divided by b leaves me with 1y. Distributing my b across, well, that's going to be negative a over b times x and negative c over b. So the slope is written as negative a over b, and the y-intercept can be written as negative c over b. Okay, and I would recommend that you learn that, kind of by heart, really. I mean, you don't need to, 100% need to. But if I look at any line that's written in standard form, and I know this rule, the slope is always going to be negative the coefficient of x divided by the coefficient of y. Negative a over b, that's the coefficient of x divided by the coefficient of y. And the y-intercept is always negative the constant over b. Well, then I can fairly easy figure stuff out. So if I had something like 2x plus 3y minus 7 equals 0, I know the slope is going to be the negative of the x coefficient divided by the y coefficient. And the y-intercept is going to be the negative of the constant, negative 7, over the coefficient of y, which is of course 7/3. And I could graph that line because I know its slope and I know its y-intercept. Okay, so standard form of the equation of line crops up frequently, and we're often asked to give our answers in standard form. Okay, so two equations of the line we've looked at so far. We've looked at the slope-intercept form and we've looked at standard form. In our next lesson, we'll be looking at introducing something called point slope form. So practice that. Remember, GeoGebra very useful for all this stuff.